How's it going, Charles? I'm going on to Optimization Applications, working from slides 1 to 14 from the Differential Calculus handout 4. All right, so the first question is saying the sum of two positive integers is 8. Determine the integers whose product is a maximum. So we have two integers here that we don't know. So we can say x plus y. That is the sum of two integers, and they told us that is 8. Okay, and they want us to maximize the product of these two integers. So I'm going to make another thing here. P for product is x times y. So that's the product. Now they want us to maximize this product. And to find maxes and mins in calculus, what we have to do is we have to differentiate. So as this stands, I can't differentiate this because it's in terms of two variables. So what I'm going to do is I'm going to use the other equation to substitute for one of these variables here to get it in terms of one variable. So if I have a look here, I'm going to solve for y. And I can get y is equal to 8 minus x. Now, if I substitute this y here to be 8 minus x, you can see that this whole thing here will be in terms of one variable, which is x. Then we can differentiate. So let's take this now, and we're going to sub it into here. So we'll get p is equal to x, 8 minus x. If I just distribute to get rid of the brackets, we'll get p is equal to 8x minus x squared. And I remember what they want us to do here. They want us to maximize this thing. So if we have a look here, if I had to plot this thing, this would be a parabola, and it would be a sad parabola because of that negative. So we know it would look something like this if we had to plot it. Now, a sad parabola has a maximum turning point, which is about there, okay? And that's exactly what they want us to do. They want us to find the maximum of this product. And because this has a maximum turning point, that is what we're going to be finding. So to find this max, what we have to do is we have to differentiate this thing with respect to x. So it'll be differentiating p with respect to x. And you remember, to find maxes and mins, we take the derivative and we set it equal to 0. So I'm going to differentiate this, and we get 8 minus 2x equals 0. And now what I do is I just solve for this. So we get minus 2x is equal to minus 8. Divide by the minus 2, and we get x is equal to 4. So I have the one variable. Let's find the other one. Or the one integer. Let's find the other one. So I'm just going to take this value and substitute it into there. So we get y is equal to 8 minus, and our x is 4. So 8 minus 4 is 4. So our two integer values that will give us a maximum product whose sum is 8 is 4 and 4. If you guys want to practice on these type of ones, you can try exercise 9.4, numbers 1, 2, 3, 8, and 9. Okay, going on to example 2. Example 2 says that we have a rectangular box with the given dimensions, and our dimensions are, this breadth is 7 minus 2x, this length here is 4x, and our height is x. Okay, so question A. Determine the volume of the box in terms of x. So we know that volume is equal to length times breadth times height. Okay, so our length here is 4x times our breadth, which is 7 minus 2x, times the height, which is x. All right, great, 12. So what I'm going to do here is I'm just going to skip a few steps. And what I'm going to do is I'm going to say that 4x times x gives us 4x squared. Now that 4x squared still needs to be distributed into both of these terms here. So 4x squared times 7 gives us 28x squared. Okay, then that 4x squared times minus 2 will give us minus 8x cubed. All right, so that's what they wanted, the volume in terms of x, and we have it. Then question B. Question B is saying calculate the value of x for which the box will have a maximum volume. So to find maxes or mins, we differentiate and we set it equal to 0. So we're going to differentiate the volume with respect to x, dv dx, and we set that equal to 0. So if we differentiate this, we get 56x minus, and then that will give us 24x squared equals to 0. So what I can do now is I can take out a common factor of x, and we're left with 56 minus 24x equals to 0. So that means we get x is equal to 0, or 56 minus 24x equals to 0, minus 24x is equal to minus 56. Divide by the minus 24, and we get x is equal to 7 over 3. This one's already solved. We don't have to do anything. Okay, so now which one is it? Is it this x is equal to 0 or x is equal to 7 over 3? Well, let's interpret our answers by this real-world application here. If I make x 0, here we're going to get 7. There we will get nothing, and there we will get nothing. So we're just left with a line. So we don't have a box, okay? So this is a minimizer. All right, because there is no box, that is the minimum size of a box, is no box. So that one is not what we're looking for, because the question is asking a maximum volume. Okay, so it has to be this 7 over 3 value. All right, going on to example 3. Okay, so example 3 is saying the sum of the height of a cylinder and the circumference of its base is 10 meters. So if I just draw a little rough thing here of a cylinder, our height is some value h, okay? And then we have a radius for this circle up at the top, some kind of a radius r. And so what we've got here, they're telling us that the sum of the height of this of h of a cylinder and the circumference of its base is 10 meters. So I know that the sum of the height, h, plus the circumference, now the formula for circumference is 2 pi r, and that sum gives us 10. Okay, so that's just the information that they've given us there. Then question A goes on to say, if r is the radius of the base, we have to show that the volume, so I'm just going to put it on the side here, and the volume is a function of your radius, is pi r squared 10 minus 2 pi r. Okay, that is what we have to show. And I just want to underline that in red just to show that is not part of our calculations. Okay. So we know that the volume of a cylinder will be equal to the area of the base times the height. So the area of the base is pi r squared. So we have pi r squared times by the height of this thing. Okay, but if you have a look here, this whole, what they want us to show, this whole thing is in terms of r. Okay, so I need to get rid of this h, and I'm going to get rid of that h by this other formula that we have here. So I'm just going to arrange it so h is on its own. So we know that h would be equal to 10 minus 2 pi r. Now I'm going to substitute that h to be this value here. So we get pi r squared multiplied by 10 minus 2 pi r. Okay, and that is a function of r. And that is exactly what they wanted us to show. Okay. Then question B. Question B is saying calculate the value of R for which the cylinder will have a maximum volume. So what we're going to do is we're going to differentiate this thing with respect to R. But I can't just differentiate this just yet. So I'm just going to distribute this into the bracket, and then we have terms, individual terms that we can differentiate. So V function of R, if I multiply that in there, I'll get 10 pi R squared. Multiply that in there, we get minus 2 pi squared R cubed. Okay. Now, grade 12s, don't freak out with the pi squared and stuff like that. It's just a number. Pi is 3.1415, and it goes on and on. It's just a constant, okay? The thing that we are interested in is the R, the variable. So we're going to now differentiate this thing because we have individual terms. So we're going to differentiate the volume with respect to R and set that equal to 0. All right. So if I differentiate this first one, we're going to get 20 pi R. Differentiate this one, we get minus 6 pi squared R squared equals to 0. And you see, I didn't do anything with the pi squared. Okay, it is just a constant. Now we're going to solve here, so I can take out a common R, and we get 20 pi minus 6 pi squared R equals to 0. I can solve here, so we get R is equal to 0, or 20 pi minus 6 pi squared R equals 0. I'm going to solve here, so we get minus 6 pi squared R equals minus 20 pi. Divide by the minus 6 pi squared, and we get R is equal to, now 20 divided by 6 in its simplest form would be 10 over 3. And then that pi, we would have a pi at the bottom. Okay, so it's 10 over 3 pi. Now, let's interpret what these solutions are giving us. So, if our R is 0, that doesn't mean, it means that we don't have a cylinder. So this is a minimum, okay? Now, remember what the question was saying? We want to find the maximum. So we don't want a minimum, so that one's not applicable. So our R value that will give us a max is this 10 over 3 pi. All right, going on to question 4, or example 4 rather. They're telling us that a point A lies on the curve f of x, okay, and f of x is given as this, and point B lies on g of x, which is given over here, okay. They want us to show that the length AB is 2x squared minus 10x plus 16. So I'm just going to write it over here. They want us to show that L of x is equal to 2x squared minus 10x plus 16. Okay. Now you remember, to find lengths, if it's a horizontal or a vertical line, we either use the x or the y values. So in this case, because it's vertical, we're going to use the y value. So it'll be the y value at the top minus the y value at the bottom. So we can see here, if I immediately call it L of x, will be equal to the y value at the top. So it'll be the y value of A minus the y value at the bottom, which would be the y value of B. Now just remember with these function notations, f of x is the same as saying y. So we have here y equals this thing. Exactly the same thing for this. G of x is y. So we have y is equal to that. So this would give us our y value, and this would give us our y value for A and B. Okay, so our y value at A is this one over here. So we have x minus 3 squared plus 7 minus the y value at B, which is on G, is this. Okay, so I'm just going to simplify this. So if we FOIL this out, we get x squared minus 9x plus 9 plus 7. Over here, if I multiply that in there, we get 4x with the negative, so it gives us negative 4x. And then that gives us minus x squared. With that gives us plus x squared. Okay. So what have we got here? Sorry, this is not 9x, this is 6x. Sorry, grade 12s, because it's minus 3 minus 3. Okay. So if I simplify this, we get x squared plus x squared gives us 2x squared. So those are gone. Then we've got minus 6x minus 4x gives us minus 10x. And then we've got plus 9 plus 7 gives us plus 16. Okay. And that is what they wanted. All right, so we've shown them that. Then question B. Calculate the value of x for which L is a minimum and hence determine the minimum length. So what's happening here is that this AB line can move, okay? And somewhere along here, it'll be the shortest distance between the two graphs, okay? No other length along here will be shorter than that. And that is what we want to find, okay? So you remember to find maxes and mins, we differentiate. So it's dl dx, and we set that equal to 0. So I just want to have a look at this thing here. If we had to plot this, this would be a parabola and it would be a smiley face. Okay, and its turning point would be somewhere over there. And with the smiley face parabola, you've got a minimum turning point. And that is what they're asking. They're asking for the minimum length. Okay, so let's differentiate this. So that would give us 4x minus 10 equals 0. So 4x is equal to 10. So x is equal to 5 over 2. So now we found the x value that will give us the minimum length. But they go on to say, hence, determine the minimum length. So what I need to do is I need to take this x value and put it back into our length formula. So now it's L of 5 over 2 equals 2 5 over 2 squared minus 10 5 over 2 plus 16. And if we work that out, we will get that L 5 over 2 is equal to 3.5. So our minimum length between those two is 3.5. Okay. Example 5. So example 5 is saying the equation of f is given by 3y plus x minus 27. So that is our straight line over there. And the equation of g, which is our hyperbola, is given by xy is equal to 3, where our x values are greater than 0, because we only have the one arm for our hyperbola. Okay. It goes on to say that AC, where this is C, AC is perpendicular to the x-axis. Now that's important, grade 12s. A line going like this that's perpendicular to your x-axis means that any point along this line will have the same x value. In other words, A will have the same x value as B, will have the same value as the x value of C. Anything along here will have the same x value. Okay. The question goes on to say, determine the maximum length of AB if A lies between R and S. Okay, so A lies between these 2 points here. Now remember, this can move along here. Okay, and you can see that this AB line will get smaller as it goes up there, smaller as it goes there. But what we want to do is we want to find the maximum length of this. So remember, it's a vertical line, so it's the top y value minus the bottom y value. So we're looking at this A, which is on your F. I want to get this in the form y is equal to mx plus c first. So we get 3y equals minus x plus 27. I'm going to divide through by 3. and we get y is equal to minus 1 over 3x plus 9. Okay, I'm going to do the same thing for this one here. We get y is equal to 3 over x. Okay, so this is our y value at the top. This is our y value at the bottom. And I'm going to call it L of x for length. Okay, so L of x is equal to, our top one is minus 1 over 3x plus 9 minus our bottom y value, which is 3 over x. Okay. So there's not much we can really do with this. We can't simplify it. There's no like terms. The only problem is, before I differentiate, I need to sort this out. Okay, so just to sort it out, all I'm going to do is I'm going to bring the x to the top, and it becomes a negative exponent. Okay. Now I'm ready to differentiate. So we're going to differentiate the length with respect to x, and we set that equal to 0. So if I differentiate this, I get minus 1 over 3. That falls away. This here will give us plus 3x to the minus 2 equals 0. All right, so grade 12, so I'm going to miss a few steps here. First of all, I'm going to multiply up by x squared, because just remember that minus means it's in the denominator. Minus, multiply up by x squared, and then multiply up by 3. So we get here minus x squared plus 9 equals to 0. Okay, so let me say that again. That x to the minus 2 is in the denominator, so it's 3 over x squared. So I multiplied it up. Then I multiplied up by the 3, and I get that 9. Okay, just divide through by the negative, and we get x squared minus 9 equals 0. I can factorize this. We get x plus 3, x minus 3. So x is equal to minus 3, or x is equal to 3. Now, which one is it? We can't have this one because they told us right in the beginning that x is positive. So this one here is non-applicable. Okay, so the x value that we're looking at is this one over here. But they told us, they said determine the maximum length. So what we got here is the x value that will give us that maximum length. Now what we need to do is we just need to find it. So I'm going to take that x value and plug it back into our length function. So let me make that x a 3. So it's L of 3 would be equal to minus 1 over 3 times 3 plus 9 minus 3 over 3. Okay. If you pop that in the calculator, we will get a maximum length of 7. Okay. Right, going on to the last question. Oh, let me give you some exercises for this one first. So what you can do to practice this is exercise 9.4, numbers 12 and 13, and then exercise 9.7, number 9. All right, last one, grade 12, example 6. So example 6 is telling us rectangle PQOR is inscribed in triangle AOB. Now inscribed just means that it's inside the shape. So what we have here is we have a rectangle inside the triangle where O is the origin. They told us that A is the point 0,3, B is the point 30, and P, which is a variable point, is XY. So P is over there. So it can be anywhere along this line like this. It can move up and down, and you can see the shape of your rectangle will change depending on where P is. So question A, show that the equation of the line, and they're talking about this line AB, is y is equal to minus x plus 3. So that's what they want us to show. So that's pretty easy. First of all, what I'm going to do is I'm going to find the gradient, and the gradient is y2 minus y1 over x2 minus x1. And I'm just going to be using my point A and B for that. So we've got here 0 minus 3 over 3 minus 0. So our gradient, that's going to give us minus 3 over 3, which is minus 1. So we have our gradient. So y is equal to mx plus c. We know what our m is. Y is equal to minus x. Now, our c value is our y-intercept. So it's cutting the y-axis over there, and that is 3. And there you go. We've shown it. Okay. Question B. Question B is saying, show that the maximum area of PQOR is half the area of triangle AOB. All right. So what I need to do is I need to find the area of our rectangle first. Okay. So what we're going to do is we're going to choose whatever x value it is, some x value along here. Now, if our x value is along here, then P will have the coordinate xy, right? We said that earlier. But what is our y value? Our y value is this thing over here, all right, depending on what x is, and we've chosen that x value. So if I draw a little rough thing of this, our length will be some x value, and our breadth here will be this y value, which is minus x plus 3 value. Okay. So how do we find the area for a rectangle? Well, area, and this is going to be in terms of x, is equal to length times breadth. So our length is x times our breadth, which is minus x plus 3. So if I distribute this, we get minus x squared plus 3x. Okay. So we're getting somewhere with the rectangle. Now, if we look at the triangle, we know that the formula for a right angle triangle, the area is equal to a half base times height. Okay, so what is our base's length? Well, it's whatever this x value is up to b, so that's 3. So we get a half times 3. And what is our height? Well, our height goes up to a, and we know that length is 3 as well. So we get 3 times 3 is 9, so this is 9 over 2. All right. So what I want to do now is I want to find the maximum area of my rectangle, because the question is saying show that the maximum area of a rectangle is half the area of the triangle. So we know our area of our triangle. Now I'm going to find the maximum area of our rectangle. Got it all in terms of x. Also, another thing I just want you to note here, this is a sad parabola, and it has a maximum turning point, and that's what they're asking us to find, is a maximum area. So let's differentiate this, dA dx, and we set that equal to 0. So we get here minus 2x plus 3 is equal to 0. And we get minus 2x is equal to minus 3. So x is equal to 3 over 2. I'm going to take this, put it back into here to find out my maximum area, because this x value gives us our maximum area. So a of 3 over 2 is equal to minus 3 over 2 squared plus 3 times 3 over 2. And if we work that out, that should give us 9 over 4. Let's just have a look, see. So we get minus 3 over 2 squared plus 3 over 2. And 9 over 4. And we have proved it, okay? Because 9 over 4 is half of 9 over 2. And that's it, grade 12. So if you want to practice on these type of ones, exercise 9.4, number 14. Okay, thanks guys.